Good morning, Pirates. This video is for Thursday, April the 30th, 2020. And today is Hairstyle Appreciation Day. Boy, a lot of people are going to be running to the hairdresser when this lockdown's over. And National Honesty Day. Our lesson today covers thermochemistry calculations, specifically talking about heat, mass, temperature change, and specific heat. The formula for finding the heat of a reaction is Q equals C times M times delta T. Or if I put that in words instead of symbols, heat equals specific heat times mass times temperature change. Delta T means change in temperature. Okay, let's break down these terms. Heat, which we represent with the letter Q, is the transfer of thermal energy between two bodies or objects at different temperatures. So our example here, the ice is making the hand cold and the person's hand has melted the ice. You can see the liquid dripping off of it. You're already pretty familiar with mass, which is the lowercase m. Mass is the measure of how much matter or atoms is in an object. The more mass you have, the more atoms you have. This also means the more energy is going to be required to make the atoms vibrate faster, which means they'll heat up. Specific heat, we represent this with the lowercase c. It's the quantity of heat required to raise the temperature of 1 gram of a substance by 1 Kelvin or 1 degree Celsius. The specific heat is literally very specific to the substance you're discussing. Every substance has its own specific heat. Temperature change, or delta T. It's the quantitative measure of how hot or cold something is. We will be using the change in temperature, or the delta T, for our calculations. The difference between the starting and the ending temperatures is the change. Okay, so that is the definition of all the things in this equation. We are going to do an example problem next. So my example problem, a flask containing 850 grams of water is heated until the temperature of the water increases from 5 degrees Celsius to 35 degrees Celsius. How much heat did the water absorb? And here's a hint. The specific heat of water is 4.184 joules per gram degrees Celsius. So we're going to do like we did all year. Our formula, remember it's Q equals C times M times delta T. We're going to take those variables and list them down the side. We don't know the heat. That's what we're looking up. How much heat did the water absorb? They gave us the specific heat as a hint, so we're going to label that as C. M is the mass, and T is the temperature change. It changed by 30 degrees. Okay, we've labeled our variables, and here's the equation. So here I've plugged in the numbers for the equation. Don't mind the purple and the numbers. I just forgot to change the color. So we don't know Q, but we do know our specific heat of water. They gave it to us. That's the 4.814. And we're going to multiply that by the mass, 850 grams. And we're going to multiply that by the change in the temperature. It changed by 30 degrees Celsius. When we multiply these three numbers, we find out that the heat it absorbed was 106,692 joules.